Now quickly reset the dais, ladies and gentlemen, and bring forth our panelists for digital energy grids and the emerging era of energy internet. And this session is partnered with Impresa.ai. And I'd like to say, as the world races towards a net zero future, the power sector stands at the cusp of a digital revolution. And the traditional grid is no longer just a system of wires and transformers. It is evolving into a digital energy grid, an intelligent, data-driven network that integrates distributed energy resources, electric vehicles, and advanced storage systems. So this transformation, often called the energy internet, harnesses the power of IoT, AI, blockchain, and big data analytics to enable real-time monitoring, peer-to-peer energy trading, predictive maintenance, dynamic pricing. And I'm going to request you, ladies and gentlemen, to please be a part of this very, very compelling session. We're going to be just resetting the dais, and we'll be inviting our chair for this session, Shri Pankaj Kumar, MD, UPPCL. The moderator for this session is Dr. Rahul Tongia, founding advisor, ISGF, and senior fellow, CSEP. And our eminent panelists who are going to grace the stage are Shri Sujit Nair, co-founder and CEO, FIDE. And we will also have presentations by Ms. Vishakha Chavan, Associate Product Manager, Impresa.ai, and Ms. Shashi Bala, Senior Engineer, ISGF. Also, our eminent panelists will shortly grace the dais. Mr. Samantha Santadyuti, Chief Digital Transformation and IT, Tata Power Company. Shri Adarsh Nagarajan, Consultant, BRPL. Shri Manoj Muthayala, Senior Director, Sales, Impresa.ai. Our eminent panelists already joining us. Not wasting any time. Shri R.S. Selvam, BP R&D Stelmec, Shri Ravi Jagannathan, MD KRYPC, Shri Subramaniam Pulipaka, CEO NSE FI, Shri Mohit Bhargav, Country Director, India Energy and Climate Center, UC Berkeley. So that is our very, very eminent panel. Ladies and gentlemen, let's have a huge round of applause for our chair, Shri Pankaj Kumar, MD, UPPCL. Dr. Rahul Tongia, Founding Advisor, ISGF, and Senior Fellow, CSEP. We've got our presenter on the day, Sujit Nair. Mr. Sujit Nair is the co-founder and CEO of FIDE. And our eminent panelists, Shri Samantha Santadyuti, Chief Digital Transformation and IT, Tata Power Company. Shri Adarsh Nagarajan, Consultant, BRPL. Shri Manoj Muthayala, Senior Director, Sales, Impresa.ai. Shri R.S. Selvam, VP R&D Stelmec. Shri Ravi Jagannathan, MD, KRYPC or CRIPC, and Shri Subramaniam Pulipaka is not going to be joining us, but we have Shri Mohit Bhargav, Country Director, India Energy and Climate Center, UC Berkeley. And there are going to be two presenters who will be joining us from the audience. One, of course, is Ms. Vishakha Chavan, Associate Product Manager, Impresa.ai, and Ms. Shashi Bala, Senior Engineer, ISGF. And with that, I'm now going to request Dr. Rahul Tongia to please carry forward the proceedings of this session.
Thank you, Reena. Thank you, everyone. It is the tail end of a long and important day, but now we can really think about the future. So how many of you were excited by the previous session on technology because it's an enabler? Now here we're going to have an even more important session in some way because we're dealing with not just pure technology, but systems, platforms, and really transformation of the power grid. It's not about, can I use IT to make it faster? It's really about, can I use technology to make things different and better? So you would have heard, of course, the Ministry of Power has set up a task force for the India energy stack. So this is really guided by this recognition that we have technology and energy, and people talk about their convergence, but it's really what is the possible future, what we have to enable today. It's not just overnight, so there is some deep discussion to be done, but at the same time, how many, if I told you 10 years ago, or 12, कि 2 रुपए का सब्जी वाले से पैसा आप फोन से उसको दे सकते हो, instantly, virtually no transaction costs, what would your reaction be? That UPI, how much of an important protocol it has become. And it's not just, of course, a technology, but something that brought together a group of stakeholders, including clearinghouse mechanisms and many other ingredients for which we have the stakeholders here today to have this discussion. We've heard already today that we have issues of winners and losers. Ashish Goelji mentioned that in the morning. But really, we want to come back to the transformation of the grid. You would have heard this phrase that the old power grid was centralized, coal heavy in India's case, power flew in one direction, top down. Now we have a transformation where more transactions can occur at the edge, that is pretty obvious, but also the dynamics when you plug in your EV will be a critical factor for the grid in the future. It's not how much load the EV has, but when it transacts, from what source it transacts, and at what price it transacts. So all of these now become variables, things that will evolve, and that is where we need new ideas. And so with that session, I'm delighted to have our chair, who will give us remarks towards the end, but more than that, to kick us off and to explain a little bit about how we can think about transformation instead of just speeding up your processes as is. I invite Sujit Nair, another co-member of the task force with me and Reggie, but also the CEO of the FIDE, the Foundation for Digital, and co-creator of the Beckn protocol.
That's right.
If I got it right.
Yes, thank you. Thank you, Rahul. I know we are at the tail end of this conversation, and this should not be another death by presentation for all of you. I do want to invite you to a few frames, leaning on the context that Rahul just said about how do we think about transformations that has to work at scale. And I see here myself, no pressure, no nervous, but I have to first start with this admission that I'm not by any measure of imagination and energy or a utility expert. So sometimes I wonder, when I stand on this podium and speak to you, to all the experience, wisdom and knowledge that is out there, I don't know what exactly I'm going to talk to you that will make you think that I do have some practical insights to offer. But I would take that benefit of, probably making you think about the work India has done on concept of digital public infrastructure and how that offers a certain way of thinking. Probably that could be useful in this very important juncture of the utilities and the grid transformation and how we think about making electricity more accessible to the whole of humanity. So with that, I think I have about 5 minutes. I don't want to intend you to do a lot of slides, but I want to start off by saying that I am a general purpose technologist. I'm more of a digital plumber who had the good fortune of being part of some of the large Indian transformation programs like Aadhaar, UPI. And most of the time I walked in not as an expert in identity, not as an expert in payments, but asking questions very differently. And for me, most of the inspiration comes from what humanity is built at a humanity scale infrastructure. So I'm a big student of humanity scale infrastructure. And I think the two biggest humanity scale infrastructure we have built one is internet, of course, and I'm an eternal student of the idea of internet, but also the grid. I think the most complex machinery humanity has ever built. So it's inspiring to be here to talk about the intersections of both of those and the possibility it's offering, particularly in this decade, and the kind of momentum and the aperture of impact this confluence of both the internetization and the grid modernization conversations are going. So with that, I think one of the first frames I want to bring to your attention, and I'm assuming I would make this clicker work. Great. So it's fascinating. I spoke about the grid and the internet. I think this is a tale of two engineering systems that we are talking about. One system at a humanity scale is ability to move electrons. And thanks to Kirchhoff's laws and the way the grid is designed, we can make an electron reach any point by playing with voltage and resistance and make this. And it almost looks like we can make this all work in a unified manner. We did not build a grid, one for light bulbs and other for toasters, right? We built one common grid for all electrical appliances. And I don't have to say this to this audience, it's like preaching to the choir, but when you talk about digital, a space that I understand a bit more, it looks like as if we are building a road for every car. Imagine we are trying to build digital systems that don't talk to each other, each of them wanting to have its own highway. And that sheer question made us think, why is that? Why is that we built a shared grid for any sort of electrical appliances? And why is that? When you talk about digital energy solutions or digitization in general, I do a lot of work in commerce and other places. I see the same pattern, even outside of electricity sector. Is that why is that we are building purpose-specific digital systems as if literally we're building one road for Ferrari and another road for school bus when it comes to electricity? And that was one of the reasons why I started getting interested in this topic and thinking about what is that we can do differently in this space. And about 3 years ago, firstly, when we started Beckn protocol and the whole work, which is inspired by the last 15 years of digital transformation, the way of thinking and way of designing for population scale, be it Aadhaar, UPI, Beckn protocol, between me, Nandan, Nilekani, and Pramod Verma, we thought of this design of solving this for things beyond money, about moving value, be it in commerce, mobility, and other areas. We did not think about electricity. In a million years, I would have never thought that an idea like Beckn protocol would find its relevance in energy. But here's the thing. About 3 years ago, we had some energy companies, energy startups, all asking us, inviting us to pay attention to what seems to be a very, very important transformational phase globally. We are looking with electricity. Of course, huge electrification that's happening. We are looking at load growth in most parts of the world, which are unprecedented over the last 2 decades. A massive electrification of mobility, industries in general, this whole pressure for going green. And the point that Rahul mentioned about things getting decentralized, bidirectional, hyper-localized. We're going from a few hundred generators to a million, solar and micro generators, and this concept of, as Ashi teaches me, distributed energy resources, DERs, all happening up. And all of these are unscheduled, non-dispatchable, very poorly observable from a grid vantage point, all behind the meter suddenly shaping up. And then there's huge, massive demand coming through, and there's this pressure for going green and pushing more, intermittent renewable energies, right? We are looking for reliability and flexibility at the same time. We wanted the grid to be robust, and robust doesn't mean that the coordination has to be totally rigid. At the same time, it cannot be totally chaos. So it's creating a whole new situation for asking different questions about what works at scale with this kind of complexity. And the more I started looking at it, I realized that the digital side of grid, as I was mentioning earlier, the flow of bits, is broken across the value chain because they're literally built in isolated trenches. The systems don't talk to each other because there is no shared highway. And I thought maybe there's an opportunity to think about this and put this idea forward, because that's what India has been building. India has been building shared highways, digital roads, or digital rails over the last 15 years, which is now globally recognized as digital plumbing infrastructure. And each of these are not complex systems. Aadhaar is a 2 API system. It only has 2 APIs. It doesn't do anything more than enroll and authenticate. It doesn't know whether you're eligible to be a citizen. It doesn't know whether you're eligible for ration or a license. It just says it tells you who you are. So all of this are built as a very, very simple atomic, almost like a single functional building block. But each building block was built for a population scale. Each of them works at population scale. And when these building blocks come together as a bunch of Lego blocks, you suddenly see economy shaping up differently. As we have seen, when you have a village and you put a road through it, it becomes a town, and then it becomes a city. We are building these digital roads. India has been building this. Thanks to GSTN and FASTag, India is one unified market. With Aadhaar, eKYC costs have plummeted, and the graph that you see on the side tells you the story. India went from 18% banking penetration in 2009 to 85% banking penetration in less than 10 years. No country has ever done that. By any estimate, it would have taken 5 decades. India did that in 9 years. Not because India's banks were not digitized. For a good amount of time, Indian banks were getting digitized. They were doing core banking systems. Yet, it needed something beyond what they do as internal digital systems to something more external and common and shared. And instead of taking banks to villages, we took banking to villages thanks to the ideas of eKYC, UPI. Today, UPI, as Rahul was mentioning, is no more just technology. It's a population scale habit. It has seeped through the fabric of the society so much that, I haven't been to an ATM for almost 5 years now. So that way of transformation by building common roads, and all of these are a bunch of specifications, a bunch of open source specifications with which public and private innovations started spiraling off. I just thought I'd leave that as a second frame of thought for the discussions here today. And all of these are built on principles that we learned the hard way over the 15 years. The idea that it has to be built as building blocks. The more and more purpose-specific designs we do, the more and more the rigidity comes in and it doesn't work at scale. What works at scale is different from scaling what works, and that requires unbundling. Think of not trying to do it as an open heart surgery, but more about an incremental +1 and work with the ecosystem. Distribute that ability to solve. On UPI, it's not just banks who solve for adopting UPI. We created a whole new ecosystem of UPI apps which did not exist before UPI. Suddenly you have PhonePe, Google Pay, Bheem, all of that coming, which are non-bank entities, but expanding the market from, before UPI, the payments in India was about 100 million transactions, 130 million transactions a month, to now 20 billion transactions. Now, we can always argue that payment is different, UPI is different, energy is different. I agree, that's beyond the point, that the comparison is not literal. But the way of thinking, the principles behind the design could be quite relevant in any complex population scale transformation. Now, which made us wonder, why is it so complicated for this collective wisdom in the room to not think about, in addition to whatever digitization we are doing as an independent utility, as a transmission company, or an EV charger company, you have to do that. But if you really want returns on those investments and make it work, you probably don't have to do these foundational elements all by yourself in silos all over again. What if some of these foundational elements were available as building blocks, as common rails, not just within the sector, not just across the energy value chain, but it also creates intersections with the rest of the economy. Because it's the rest of the economy. We are seeing electrification happening. Industries are getting electrified. Cities are chasing net zeros globally. You're looking at mobility getting electrified. If we have rails, and if we can bring financial services, green financing, subsidies, streamlining for solarization at a much faster rate, if you can bring the rest of the intersections of the rest of the economy to work with you to solve this huge energy transformation problem, sometimes it feels that building a common energy rail, as simple and minimal as it can be, if you can build common energy rails, a common set of open specifications that is purpose generic and universal, not one standard for smart metering, not another standard for demand flexibility, not another standard for telemetry on transformers and substations, but if you have common set of building blocks that is purpose agnostic, that caters to any application of energy as a bunch of small building blocks, maybe there's an opportunity. So this was pretty much the limited insight we had about what is that we need to do differently. And so we worked on that. We had some consultations. We worked with a few utilities in India and globally to frame that vision as digital energy grid. And that's a paper that we co-authored with India International Energy Agency, and we launched it in Paris in February. And the idea is very simple. I mean, if there is nothing, so for example, today you have UPI, Amazon's, Uber, Namayatri.
Request you to...
Yeah, I'll just close it up. Yeah. So if you have, all of them exist because there's a common rail of internet, and there's nothing in the design of internet that will tell you that there'll be an Amazon or a ChatGPT 50 years later. Maybe it's about time we built a similar HTTPS of energy, And that's essentially the idea. We are seeing some implementation already. Some of the principles are informing India Energy Stack, and I'm one of the task force members working with the architect. And we are seeing some early implementations of this. These are live transactions that are happening. Some of the startups here are already doing some of the work. Very happy to report that we did our first elementary pilot with ISGF on peer-to-peer trading with the UP regulator and UPPCL, and some of the other conversations with other utilities. But I'll leave you with this slide. This is exactly what we are trying to do. Think of DEG as a way of thinking, as a way to just add this to your toolkit about how you're thinking about modernization of the grid, and see if this makes sense. I'm happy to be part of those conversations. Just a bunch of functional building blocks, all open specifications and protocols, and make it work. And some of these building blocks are pretty straightforward. Any device connected to internet gets an IP address. Is it possible to get an energy device addressability for utilities? It's not complicated. It's been done before several times. We've done that with zip codes. We've done this with telephone numbers. We are doing that with internet. Can we do this for energy? With the current form of digitization and cryptographic technologies, it's very much possible. And the whole bunch of things that comes out of it is pretty straightforward. This makes any energy device addressable, observable, traceable, transactable, so that grid has more observability and ability to control this, whether it's behind the meter, in front of the meter. If everybody starts speaking the same language, then you have a common infrastructure to work with. I'll stop here. Some of these are technical details. I'll leave it here. It's not an open heart surgery, as I was saying, and it can be adopted at every level. We can probably do it from one specific application of EV charging to a whole grid modernization for the whole of the country. The fundamental principles remain the same. Yeah? Thank you so much. Thank you.
Thank you, Sujit. We'll move to brief presentations on more practical and applied cases. But before that, two quick observations and a small joke, not joke, but light-hearted vein. It's not heart surgery, it's harder because the power grid is real time. The internet can have a timeout and retransmit. The electricity system cannot wait and retransmit the electron. So there are two things I think that are important for us to take away as we think about this. The first comes from what you said was use cases. That's really your job. Every single person here, what do I want from this? All of this stuff is an enabler and a means for an end. So no one else can do or should do your homework. Ki mera pain point kya hai? Where is my value proposition? Then the details of which, how and all, there are experts who can help you with that. In the past, we used to socialize this entire cost structure. When you transact, you look at, well, there's different bijli at different times, different greenness, different brownness, different cost, and there is aggregate revenue requirement and average cost of supply, these two terms that you know all too well, and they're balanced. But now you can, with this sort of a system, incentivize behavior at the margin. Instead of just saying, on average, this is your cost. Well, today, I would assume none of you are worried ki, what time do I plug in my EV? Okay, spot of show of hands, let's wake people up. How many of you have an EV? Let's raise them high, yeah. Some people have EVs, I don't, sorry. How many of you bought the EV because you want to be green? Okay, a few hands less. How many of you make sure that you charge your EV in the middle of the day? One hand, thank you. But that's what these platforms can enable us to do. Because without that, we're going to miss the trueness because we're averaging. The second, the scale with which India has pioneered DPIs is globally recognized. And part of that says, look, I don't want businesses to thrive around proprietary systems through things that don't scale, where you need 10 consultants to do one transaction. It should be easy, standardized, and if that breaks some business models of certain entities, that is the future. Because either you're not going to get scale. If you're not following these design principles, you won't get the scale or speed that we need for India. And this is something other countries have faced. I was on the Technology Advisory Board and helped design California as one of their leading smart grid rollouts now 20 years ago. And my only lesson to them was, don't buy off the shelf. Because what will be sold to you is what is easily available. Work backwards on what you need. And they pioneered open AMI, which is a precursor to many of these, what we're talking about today. So now, thanks to learning, we're at a different place in time. And so now I request very brief presentations from Vishakha Chavan, Product Manager at Impresa.ai. And hopefully you'll be able to guide us to more practical, not just abstract uses of these technologies.
Okay, thank you everyone. Thank you for having me on talking onto such a visionary topic, digital grids and energy internet. Sounds quite visionary, but isn't really much. And Mr. Sujit had very powerfully set a very powerful context as to what to consider as the base, and I'll just take it forward. Okay, we have the slides ready, so I'll just take it forward on the base with the concept of intelligence as inference. Let's start with a thought experiment. And I have a question for you all. It's not working, it seems.
Next slide, please.
Yeah. So, what if energy flowed like information online, right? We all are talking about UPI, we are all talking about different technologies that are existing right now, all futuristic, but it was all sort of visionary in the past, and the same way we are doing for energy as well. We are talking about what transitions we can make in energy, and globally, all the multiple utilities are discussing the same. But at the same time, in 2025, the world debates energy transition. India is already building it. How? We are building it using the three most synergistic foundations for energy internet. That is, number one, energy internet stack. It's a data scale backbone, which will enable you to interact data more securely and intelligently. We have the unified energy interface, which is the transaction layer that standardizes the interactions between multiple consumers, prosumers, and producers. Next, we have the utility intelligence platform. This is my favorite, the intelligence fabric that transforms all the data, because we have all the data in the world, but we want to derive actions and insights from the same. Now, just to take a step back, we have talked about transforming the energy industry using energy internet, but why is it even necessary? Right now, multiple utilities, specifically in India, are undergoing the 3D transformation. That is decarbonization, decentralization, and digitalization. Now, decarbonization is the renewable generation that is overcoming the industry right now. We have decentralization, which is distributed power generation, and digitalization, which is sort of the bridge that connects all of them together, because without digitalization, with the incoming decarbonization and decentralization, we would not have a very stable grid. All right? Moving forward, that's why we need to have digital energy grids, which is different from the traditional energy grids that we have so far witnessed and operated, with the limiting aspects as to the one-way power flow, which can be with the digital energy grid, be directed to bidirectional prosumer flows. The manual operations can be replaced with autonomous real-time decisions. The siloed systems can again be replaced by interoperable open infrastructures. The passive consumers can become active market participants, and the utility-centric model can become an ecosystem-centric model. Moving forward, now let's deep dive into the energy internet. We have 4 blocks here with us. The physical layer, which comprises of the energy data sources, the thermal, renewable, biomass, etc. Then the digital backbone that sort of connects these data and provides the data to the data systems, comprising of the digital, smart meters, SCADA, and all the other relevant legacy data systems. Moving forward, we have the data and intelligence fabric, which again is the most important aspect of all these 4 layers, because this is where the data becomes gold. We have been told that data is the data is the mine, and we have to just derive value from the mine, and this is the layer where we are going to derive the same. And below that, we have the market layer, which is the interface where the users can interact with the system. Now, all of these systems flow end-to-end, and they are codependent on each other. The data we get from the physical layer gets back to the digital backbone, which gets served to the data and intelligence layer, which gets and regulates the market layer and the operations, and that's how, again, the physical layer gets impacted. Moving forward, it's getting stuck. All right. So like we talked about the 4 base foundational layers for the energy, internet, and digital grids, Impresa.ai is built on the same utility quadruplet. We are a 4-layer intelligence framework that is designed specifically to help utilities operate in a smart and adaptive way. Number 1, we have the operational layer where we have different interfaces for automation, operator interfaces, decision execution, right? Which gets information from the cognitive layer. Again, the AI/ML based insights that are coming from the data layer, and this information comes from the physical layer. It is replicating exactly the 4-layered energy model that we saw for the energy internet, and Impresa.ai is replicating the same. Now, as we have talked about the digital energy internet, the digital grids, now we can come to the platforms that are going to serve these technologies. So we have the core digital architecture for the energy internet. Number 1, and the most important aspect is the unified digital identity. We need to have a very standard unified identity modules designed for the database, for which the data is going to be provided to the different systems. Then we need to have consent-based database, because consent, control, cybersecurity are very important aspects. I think I'm getting, okay. I thought I was getting disconnected, okay. So user control, sharing, and granular permissions and real-time revocations are very important as for the consent-based data. And finally, we have the open APIs, for which we need to have interoperability, innovation, and no vendor lock-in. Finally, we have the UIP, the analytics-driven utility platform, where the core capabilities of UIP stands as real-time grid optimization, where we need to have autonomous balancing of supply, demand, and storage, and then predictive maintenance, and P2P trading. And I'm sorry, I'm getting a little cold. It's a little cold here, and I'm getting a little cold. Can someone a little bit reduce the AC? Sorry. So P2P trading enablement, dynamic pricing, and demand response, and finally, the unified data fabric. Finally, this is the
if I could ask
UIP.
you to, bring
Yes.
it towards the concluding slides.
Yeah, it's a little cold in here, so that's why. All right, so moving to the UIP, the analytics-driven utility platform, where we see the actual model that we discussed before in operation, that is generation, transmission, distribution, consumption, presumption, and market policy and regulatory in action, where we see the data coming from the generation assets, being the outputs, the status and faults, feeding into the UIP, from which we get the UIP optimizing the data loads, and then the UIP managing the voltage, reliability, and the two-way data flow for the prosumer demand responses, and finally UIP generating insights, compliance, and analytics. But with this, there is a chance that 65 to 70% of digital grids will fail globally. Why? It's not going to be because of intent or money, but it's because of adoption and infrastructure. So these are some of the root causes that we have identified behind the global digital grids. We should not have siloed data structures. We should not have cloud-only dependencies and multiple. And the principles for which the new digital grid architecture should stand for is the unified data fabric, the edge, cloud co-processing, scalable and cost-aware design, and finally the transparent AI, where we need to have policy agreements as to the explainable and transparent AI modules.
So,
And-
Vishaka, if I could ask you to conclude, please.
Yes, this is just one of the last slides. And finally, we have the new utility intelligence checklist, where we talk about what actually is needed, that is data unification, edge plus cloud architecture, cost-optimized storage, deployment flexibility, explainable AI, 99.9% reliability, modular open standards, and Impresa.ai is already doing this for India as well as globally, where we have the different matrix mentioned here. And in the presence of time, I'll just move forward and talk about the critical moves for India for the next month, that is to deploy the intelligence with digital infrastructure, embrace open architecture, and build the ecosystem. Thank you so much.
Thank you. I know time was short, but thank you for highlighting all the issues, Vishaka. If I could now request Shashi Bala, Senior Engineer, ISGF, to share something on a digital energy actual demonstration in UP.
A very good evening, everyone. Thank you so much for having me here. I'm Shashi Bala from India Smart Grid Forum, and I'd like to give you a brief presentation on peer-to-peer solar rooftop trading using unified energy interface. This model is being implemented first time in the world. Can I have my presentations, please? Yeah. So between 2020 and 2022, ISGF has done 3 pilot projects in the past. Firstly, we start with the Lucknow with 12 participants, which made UPPCL to issue peer-to-peer guidelines in 2023. The second we did in Delhi with TPDDL, which went live in 2021. And finally, the third we did in West Bengal. The model is almost ready, which is yet to be shown to the West Bengal regulator. So these 3 pilot projects have shown that the peer-to-peer trading model is technically feasible and commercially viable in India with both prosumers and consumers. Moving ahead, UPPCL issued peer-to-peer guidelines in 2023. The motive has always been to promote solar rooftop adoption and allow safe energy exchange. These rules apply within the DISCOM area itself, and a user participating in that must be having a postpaid smart meter radio. So I'll be explaining this later in my slides. These are the few terms that I'll be using in my slides. BAP is simply the app which is used by the...
Take your time to explain as you need to. Yeah.
BAP is simply the app which is used by the buyer, and BPP is the app which will be used by the seller. Order book is simply a trading record which is recording our buyer and seller contract. DISCOM is our, as we know, is electricity distribution companies, and NPs are all the users which are participating in the network. Transaction layer is simply a layer where a trading between a prosumer and consumer taking place. Data trust layer is our blockchain layer, which is actually recording the smart meter readings and our P2P trades. As we know, AMISPs are service providers which are hired by the DISCOM to put smart meters in homes or offices. MDM are like a digital locker which is recording the smart meter readings. This actually helps the DISCOM with the billing, tracking, consumption and forecasting demand. So as Sujit has explained in depth, but just a quick overview that unified energy interface is like a digital marketplace, which is connecting all the kinds of energy systems. But today what is happening that be it solar, wind, batteries, EV chargings, they all are working in isolation like a separate island. So UEI is acting as a bridge here, which is getting together everything on one open network where a user can easily find the available energy in the market, buy, sell it, and settle it on the payment. So in short, we can say that UEI is making the market bigger, making the choices available for all. So yeah, here it is how our peer-to-peer energy network is being structured. At the bottom, as we have seen, prosumers with the solar rooftop and consumers, they all are connecting through the smart meters, which is recording the energy flow. Over and above, we have the data trust layer, the blockchain layer. It ensures the transparency and reliability and also can be used for audit trails and records. Moving ahead, as you can see on the left-hand side, we have the BAP app, which is used by the buyer, and BBP app, which will be used by the seller. As Sujit and Vishaka explained, they both are connecting and talking to each other through a Beckn protocol. So in simple words, we can say Beckn is like a set of rules, which is helping the platforms communicating to each other without really a role of a middleman. So finally, utility company is also a part of the loop. Which is managing the actual energy flow, and the trading is taking place digitally on the network. Moving
Shashi,
ahead.
if I could ask a question,
Yeah,
because
please.
it's very critical for the audience. You describe peer-to-peer, 2 panels can do. What happens to the utility? You said they are involved. So one is that physical involvement is easy.
Yeah.
Financially, what happens to
I'll
the
just
utility?
explain in this slide.
Perfect,
Yeah?
because
Perfect.
that's the key question I'm sure many of you will have.
No,
Yeah.
I'll take it, sir. So ISGF is approaching the potential users for their enrollment. If they agree, they are asked to enroll the sign-in enrollment form and likely to share in details like their smart meter details. The same detail is shared with the DISCOM for the verification process. If the smart meter is missing, they are asked to install the smart meter, and they authorize the agency to share the daily meter readings data with our blockchain layer. So here, answer to your question. So what is happening on day -1? A prosumer declares what energy they want to sell for the next day and at what price. Similarly is with the consumer. So by 5 p.m., our platform checks for both and generates the smart contract. On trading day, what is happening? The energy is flown on the grid via a smart contract, and on day +1, our platform checks the exactly adjustment. So money is debited from the escrow account, and on day +1, that money is safely distributed to our users, that is prosumer, the DISCOM, and the platform. So, answer to your question, at the end of the month, the adjustments are being made. So, we are sharing the adjustments from our blockchain layer to the RMS billing department of our DISCOM. When I say adjustment, so for a consumer, the adjustment is like how much energy they have consumed from our platform is deducted from their total energy usage. And for a prosumer, how much energy they have sold through our platform is deducted from their total energy export. So likewise, these adjustments are being calculated from the DISCOM side, and they are sharing the same adjustments with the RMS billing software through the MDM. So this slide shows the flow of the meter data. MDM of authorized MISPs, they are sharing the daily meter readings data to our blockchain layer via parser. Parser is actually acting like a bridge here. And our transmission BPP, what is happening? This makes sure that whatever is happening between all these parties, it is safe and secure. So this is storing our data from consumer and prosumer. They both are trading with the help of our payment gateway. Finally, the adjustments are shared through the RMS billing department of the DISCOM through an MDM. We have 14 network participants so far. So this was a brief about this project. I am happy to take any questions.
Thank you, Shashi.
Thank you.
So it's real. And Reggie, maybe you would like to just clarify not just the bill offsets. Okay. If we could ask our chair, because end of the day, mera kya hoga Kalia, you know, that question at the DISCOM.
I'll explain at the end.
Okay, at the end, because that will be a key thing. Sujit, did you want to just add a point?
Thanks to the early vision Pankaj and the team at UPPCL shared, we sort of designed and conceptualized. I think there are a lot more designs to be done to refine this. This is intended to be a demonstration, and there are a lot of things. But I think it's very important to your question, there are enough design choices that is allowed for utility to design it any which way. For example, I can make this a carrier billing. For every transaction, I can make it as part of the monthly meter billing, if utility chooses to do it that way. Or if you think that because it's peer-to-peer trading between the two platforms, they can do the collections of the money and act as an agency collecting on behalf of the utility and have it to the utility, so that at least the collection risk for the utility goes down and you don't have to worry with metering errors. You can also do it as a real-time collection by the utility. So all these are design choices, implementation details. It is left to what is comfortable for a particular utility. And there's a whole spectrum of that choices, right? I mean, I would assume there could be some utilities, and we are having this conversation not just in India, outside, they want to create a very clear prepaid financial product around this idea as a subscription plan. So it can be a prepaid model. Some of the utilities are thinking about this model. So all these are, the question is, does the design allow you that flexibility? If it doesn't, then it's a very rigid model. And to a large extent, three things you need to ensure, whatever the design is. It doesn't need somebody in the center to orchestrate it, because it's a huge investment and that central agency has to manage a lot. Two, the system is secure. Every transaction is digitally encrypted, digitally signed, fully green, and the privacy is maintained. The consumers and prosumers' identities are not revealed. They're completely built on privacy by design. And the trust is decentralized. So it means that the cost of regulating it is baked into the design. It's not like you have to do an extra effort to monitor this. As an institutional regulation, the architecture with cryptographic commitments, it takes care of that. So it reduces the cost of administering this network. So those were the key design principles, but there's a lot more that we can do once we start adopting this at scale. But I'm sure Pankaj and Reggie will have more questions, more thoughts on this. Yeah.
Thank you. And I think those are music to the DISCOM's ears, because this is like the early transformation when IT and computers came to schools. The teachers would ask, is this yet one more thing I have to learn? And so we want to make IT as simple as possible for the end users. So thank you to our presenters, all of you. And now we'll quickly jump into speakers and our panelists. I will first request Mohit Bhargav. I know you have a flight to catch. Luckily, I believe the airport is walking distance. So.
Yeah, I mean, it was like that. It would have been much better. But I think Sujit is also traveling, so I'm not worried. Probably we'll go. He's half an hour early, so we'll probably be able to run and catch it. So, yeah. So thanks the chair, the moderator, and thanks Reggie for having me here. Actually, after looking at Sujit's presentation, I am honestly not sure what to say, because whatever you used to think that now UPI getting a companion in UEI, and obviously I'm assuming there's backward integration in terms of the financial transactions. So when you asked how do you take care of the money, so my immediate thought was that it's much more easier to actually integrate UEI and UPI so that transaction can actually happen in real time. And I was a bit surprised when I think one of the presentations said that it's a T+1 kind of transaction we're looking at. It can possibly happen faster than we have imagined. That will be like not a real-time market, it can actually be better than that. It could be 5-minute market, 15-minute market, theoretically. The question remains whether we are having that kind of framework in place, but I'm sure that can be done. And it's kind of fortuitous that when we have UPI into place, we also have the Electricity Amendment Bill, which says that in a way, the distribution company will now have to offer non-discriminatory open access on their transmission system to any other licensee, whoever is allowed. So which in a way actually lays the foundation for a kind of retail level choice which we can have, whether I want to go with company A or company B. I know, I mean, maybe this is very good for some of the legacy companies there. Maybe it's not that good for the legacy companies there, but ultimately this is what we have been all talking about, that competition at retail level, where the choice is with the consumer. That's what we are all aiming for. I don't want to actually get into UEI because, like I was telling Pankaj, my main interest was to actually listen to Sujit and what they're trying to do. Quick 2 or 3 ideas which we have. I'm not sure whether they're workable right now, but Sujit, maybe these are things you could take. So one, of course, was the peer-to-peer thing, which is already happening, which I think would actually be done on real-time basis. What probably we are also looking at, and this is part of some work which was done by the India Energy and Climate Center, which was taken up by the government. So there have been recent notifications on AC efficiency standards. I don't know how many of you have seen. So starting, I think, 1st of January 2028, whatever is the star rating now will actually be much better in terms of efficiency. What that also means is that if you have this interface in place, the customer has a choice to actually time their energy consumption depending on what the rates are on offer. So Sujit, if this can also be part of the overall system, which makes it easier, with a mobile in my hand, that if I have to turn on my AC, I have a choice. I do it at a time when probably the pricing is the easiest, which will kind of democratize the consumption of energy. So I won't be dependent as to when and how a DISCOM is giving me power and what the billing is going to be. And I think one more area where we think that this could actually be very, very important is also, in a way, it also gives back control to the DISCOM. Because if you are enrolled in UEI and DISCOM wants to kind of bring in more flexibility in grid management. So if, for example, the grid company says, now I want you to actually bring down the load by, say, 50 megawatts, the DISCOM can actually take that decision with people who are already enrolled, with the consent already given, that there could be a proper management of the grid. So these are quick points. I don't know whether we are there yet, but I hope this leads us to that point. And I'm sure the Electricity Act Amendment Bill, which is there in place, will in a way catalyze this whole movement forward. Thank you.
Rahul, if I have your permission, just want to clarify. Peer-to-peer, it's definitely a radical idea, radical but practical as we can see it. But is that the only idea we should think about when it talks about transformation? I don't think so. I mean, that's just probably a fringe case at the edge. It does offer its value. It does make a consumer an active participant in energy, especially with solarization all happening, which is great. But the larger point here is that it's just one application. The underlying infrastructure actually gives more power to the utility, which is actually the one that can actually move electrons with an infrastructure to have better observability of things that they could not observe before. An EV charging, and I tell this to my friends, if you're an EV charger, great, but if you're buying the EV charger and charging it in the night, you're literally melting the grid. That's a bad time. You're causing more damage by driving and charging an EV charging by charging it in the night. But with the idea of a digital energy grid, with addressability and all these built in, you can observe better. You can observe better and offer some mechanisms to sort of create demand flexibility. Similarly on the other flexibility. So it says beyond this peer-to-peer, there's much more other imagination. I'll stop there.
I think, yes, the point that there are many use cases to discuss, and I would now request everyone to really focus to the extent they can on A, what are practical or relevant use cases for the utilities here, and B, we know some of the destination that we heard that Sujit laid out, but a long journey is always taken in steps. So what are these steps? Where are we? What can we do? So with that, thank you, Mohit. I would now like to turn to someone from Manoj. Since your colleague just presented, is there anything you'd like to add to that?
Yeah, so definitely I would like to add on a few parts. Like we have shared the digital or the intelligent fabric which we are talking about. We have seen the grid which are more on the stability and reliability part, but we need a more intelligent grid where we need to really operate on the various parameters which we need to accommodate now, the solar part, the grid, the EV part, the battery, the drone, all the informations need to be captured at one place. And we need to get this intelligence into the system where grid can think. I think that Indian energy stack is exactly the digital backbone which we are going to have over here. And enabling the entire utility, which I think Alok sir has said, like not just the most advanced utilities over here, but the remotest or the smallest utilities can take the opportunity or take this platform to advance themselves, and that is where we see the synergy and we can see the real fruits or benefits we can ripe about, where every utility can run on the most optimized part and give the fullest of its, the power and strength. Thank you.
Thank you, Manoj. We'll come back to more details because the devil is unfortunately in the details with a lot of this. If I could now switch to Ravi as the MD of GRIDS.
I'm going to talk about our experience in the recent pilot that we did for UPPCL. Because end of the day, the technology when you put in use and how it behaves.
Ravi, could you bring the mic closer?
Yeah, okay. End of the day, when we put a technology in use and what we experience, that matters. Because we can talk about many things, in the air. But what we have experienced here is very, very important. This will be very helpful for DISCOMs, to understand how the whole DEG, or I would call it as a DDEG, because it's a decentralized, energy grid. So, for example, we are able to see the data that start from the starting point until now. There is no change. Nobody can edit. Nobody can delete. It stays there. That means a lot, because it's a completely decentralized system and you have the data always available. That means, for example, in the earlier session we were talking about AI. if AI has to function, you need to have a trustworthy data. If there is any change in the data, then the AI will fail, or the AI, results will be very, very different from the fact, right? So that's number one. And number two, we are talking about it's verifiable. Any transaction, anybody in the system who is authorized to see the data, they can verify whether this transaction did happen and at what point in time it happened and what is the result of the transaction. They can verify. And the third important point is complete automation for compliance of regulation, because this is very important for discoms. For example, your regulation says that this should be the wheeling charge, and this should be the kind of a penalty, or this should be the rate, whatever regulation you are coming out with. Managing those complex regulation in peer-to-peer scenario is going to be highly, highly difficult if you are going to do it in a non-automated way. By having a smart contract, that's one concept in blockchain, right? It's not a contract. It is a kind of an automated code that's running in a distributed system. When you have that smart contract where we are going to put these business rules, I would call it a business rule for that all the regulatory, the compliances that we wanted to maintain, then it automatically kicks in. There is no need for anyone to check or anyone to say that this is how you should behave. The system automatically kicks in based on the data coming in. So that is one of the, when you talk about scaling, millions of smart meters connected and the data coming in, because energy end of the day it flows, right? It is not like identifiable, you don't leave any evidence. So it is important that we have a system that automates the whole thing and manages the compliance. That is very important aspect of it. The next one I think everybody is talking about is the transaction, the payment system, right? In P2P scenario, we are talking about two ledgers. One is a peer-to-peer transaction. The other one is recognition of that transaction in your monthly billing. So both need some amount of kind of a immutable transaction recorded in the ledger. So that is what I think the blockchain does. It automatically provides for information to discoms to consume in their billing system. So that is very important. If they miss it, okay, you have metadata coming in. After that, what do you do? Maybe, you need to consider that in a financial lens, right? So that's what it does. And then the last but not least is about the trust. Because when we talk about peer-to-peer, what is the transaction happen? Did I get the right amount of money that is coming to me or not? So all those relevant, kind of challenges, this trust factor is missing if it is a centralized system. If it is in blockchain, and if it is a kind of the trustworthy layer that we have put in place, so then automatically it gives that trust. So all this put together, now we are talking about the energy flow, which is kind of I would call it as a digital twin, happening in this layer, which is a DEG, and this ultimately it provides for enough information to manage the regulation, to manage the transaction, and ultimately giving that dispute-less scenario with the trust factor. This is what I think we have experienced right now. It's not like a major kind of a high number of smart meters we have connected. Yeah. It is only very low in number, but still we could see this flow. And that flow is something giving us an assurance as we grow, as we scale. I think this P2P platform, the DEG is going to be one of the excellent ways of managing the scenario, irrespective of whatever be the regulatory guidelines. Because it's very, as Sujit was mentioning, it is very flexible. We can make sure that once we understand the regulatory norms, we can fix it, and then we'll make sure that ultimately discoms benefit and peer-to-peer, whether it is a prosumer or consumer, they all benefit.
Thank you. No, I think the point of trust is not just abstract, but there's actual money on the table. How green are you? How compliant are you? These will become increasingly important as we go forward. So this is a part of the conversation. Thank you. If I can switch gears and now request Dr. Nagarajan, and maybe you would also potentially have some global insights as well, given your experience.
Thank you. Here I am representing BSES, right, a discom. With or without peer-to-peer, energy flows based on physics of the grid. least resistance path, consumption happens. Great. On top of it, we add a market mechanism through which an excited prosumer chooses to participate, right? So that's where digitization comes into existence. Here, in other parts of the world, peer-to-peer is, for the most part, owned and operated by aggregators. That's true here as well. If I ask a question, if I choose a random person in the room and ask, how many units did you consume last month? How many of them will say? Maybe 20%, 10%? I myself don't know, right? As a consumer, I'm too busy doing my job. An aggregator comes in and takes over the market mechanism, right? That's the international mechanism. Here as well, I know we are talking peer-to-peer. In the demonstration that demonstrates 4 consumers sold, these many consumers bought. In BSES, the same team here, we tried 1 consumer sold, 1 consumer bought. But it was completely asked and encouraged. If I open a market volatility on this, what % of customers actually will choose to open up their phone app, bid their energy, do a price discovery? Going to be quite few, right? Very few, in all honesty. So that's where aggregator role, virtual power plant role, I think there's going to be a severe evolution in that marketplace. And more than all, wearing a DISCOM hat here, I personally think I have great respect for DISCOM engineers and servicemen here. People are so stretched out thin. Everybody is working so hard. Any innovation we bring, any technology we bring sounds as cool as it sounds, should not add excessive work to a DISCOM environment, because at the end of the day, a job of a DISCOM is to provide reliable energy supply to all consumers. Then comes all the other innovation and mechanisms in place. So that's one thing I want to urge and request to all the committee members here on the stage and on the dais and on the participation room here. Any innovation we bring to the table, please interact closely with the DISCOMs and make sure how is it simplifying a job of a DISCOM, grid operator or a lineman or a power procurement team, not just because something sounds interesting. Otherwise, the whole idea will truly not pick up. That's what happened in other parts of the world. At least I can give first-hand experience in USA. So many DISCOMs tried this, and engineers in the DISCOM did not have time to pick it up because their priority is not innovation. Their priority is reliability, right? So we need to keep fundamentals in mind. At the same time, we need to also innovate. I'm a researcher by heart. At the end of the day, we want to innovate, also making things practical. That's why I like the idea of DEG, where when they reached out and they communicated how they can simplify a process, I was a fan of it. You simplify something, I'm your audience. You complicate things, I lose out, right? Because job is too complicated for grid operators. 1 second of reliability. Imagine 20 minutes outage happens because of a cool innovation we are doing. Who will listen to us? Right? It doesn't work out. So that's my point. As long as we are practical and we innovate, peer-to-peer will have a huge market. To summarize, the role of aggregators will be humongous in Indian market, given the population, given the scale. And I think we need to strongly interact with aggregators and make sure anything that we add simplifies the job of a DISCOM. Thank you.
Thank you, Adarsh. Bonus points for being shorter on time, but we're not keeping score. Now, you use the word aggregator as one technique. I think we will have the rise of agentic solutions, AI-based and others, where I should just give the guidance and then the system will evolve the equilibrium of whatever the consumer wants. But we've talked a lot about the DISCOM and the utility. I think you brought back the next layer or hinted to it, which is the consumer, which is really who all of us should be worrying about, not just the utility. And we want to look beyond peer-to-peer because that is just one sort of use case. So if I could request Santanjyoti to share from a utility larger canvas and larger thoughts towards this journey that we're on.
Thank you, Rahul. So, from utility, actually utility is there because consumer is there. So, I'll like to give for a long time what problem we do have. The power flowed from the big generation to the customer, whereas like when Sujit was showing CX, DX, TX and GX, if you really think current days that CX, TX, GX, DX are being fused at every voltage level, big generator or small generator is coming, as well as the transmission is no more 400 kV, it can be 230 volt also, right? So that is one big change happened. But is the entire protection system, sensory system is changed? No. One example, fault passage indicator in the 11 kV. It is still unidirectional. So the same SCADA or the ADMS applications will not work here. But from the customer point of view, if I have an EV of Tata Motor or maybe Morris Garage, I have an app, I have the visibility of their charger. I do not have the visibility which is the nearest charger at a lesser price. So that is because if you see the rooftop solar or home energy system or the EV, these are the private cloud where actually data exchange, lack of data exchange actually is creating that opportunity, is taking away. At the same time, from the utility side, I have heard that someone told to Sujit in Bangalore, probably we have some 300 gigawatt capacity of battery at home on aggregate basis. And still we are struggling for the storage, and we say consumption happens the moment it is generated, right? So we put money from one pocket to another pocket, but we cannot exchange the energy from one connection to another or from my friend to me. Or I cannot shift from one time to another time. Whereas there are 2-hour time shift between Assam and Mumbai. So demand flexibility, sometime I want that demand is to be reduced, sometime it is to be increased. From consumer point of view, actually feed-in tariff is like kitchen waste. I have put in my money, but whatever you give, I have to take, right? At the same time, if there is opportunity to sell it outside, then it's, and from the demand flexibility point of view also, I have 300 gigawatt or maybe something, but I am not able to participate. So those are the opportunities, as well as, you know that when we buy a share of Coal India, we also expect dividend, also increase in share price. So the renewable energy certificate also they can get, but utility gets the RPO, customer doesn't get. So those are the opportunities I believe is there from the customer point of view as well as from the utility and the nation point of view, which can be enabled.
Thank you. I think you flagged 2 points that are important also. One, as we look at solutions, can we also keep in mind not just new, but how it integrates with the existing hardware and solutions out there? And do we need retrofit solutions? I didn't realize the number is 300 gigawatt hours for, this is the batteries and inverters you're talking about? So a lot of people have backup. That's a heck of a lot of GWH. That now the problem is it's so distributed that the current architecture cannot touch it or handle it, A. But B, there's the second side of it is, why will I as a consumer bother? What's in it for me? So we need the economic incentive to align with what the technology could theoretically be capable of. So the lowest hanging fruit is not to try and get a consumer to give their vehicle to grid power or inverter battery to grid. Maybe you have to pay me a lot to do that. But at the very minimum, I could ask or ensure that I'm not drawing from the grid at the wrong time. That's a lot easier than trying to get me to feed into a grid as a bidirectional flow, as a need. So these are very important points. Now I request Mr. Selvan, a small PPT. So within the time limit, if I could request you to, can we load the PPT meanwhile? He's of course the Vice President R&D with Stelmec.
Hello. Hello. Yes, I am from Stelmec Limited. We are from Mumbai and Ahmedabad. We are the manufacturer of medium voltage switchgear, and we supply pan of India. And we supplied a lot of both indoor and outdoor vacuum circuit breakers.
If I could ask you to keep the mic near, it's not picking up.
Okay,
here.
okay. Yeah, oh, sorry, okay. So various time of the discussion with the DISCOM, every time they requested to make cost-effective solution for automation for a rural substation. Because SCADA cannot go to rural substation because being it need dedicated centers and as well as it is a costly. Then based on that, for of course we have supplied many more in lakhs in outdoor vacuum circuit breakers. So we thought about to connect the IoT device. So based on that IoT device, and we have made automation substation, and because that it is very easy to, initially we tried for one GSM model for every relay. Because today every substation has made it digital substation because the numeric relays are there. So then we decided the relay has to be connected in one IoT device, in one substation. The IoT device can be taken the input, various input you can take, not only from circuit breakers, transformers, battery chargers, any input. Because IoT device accept either RS485 or RJ45 connector, Ethernet port, or digital input or analog input. So that the entire substation we can connect in IoT device. Either IoT device can be operated by wireless, Wi-Fi as well as SIM. So whether 4G, 2G or 5G. So that you can, of course it will be delivered to the internet cloud network, then any number of persons from that substation operator or executive engineer can able to monitor the substation. So that the entire substation can be automated. So because rural substation, lakhs substations are there. So we made a solution and to provide substation automation by IoT device. So for which, of course, we have made simulated in our factory five numbers of vacuum circuit breaker and some of the transformer, energy meter, so that all the thing only one IoT device, so that it will be very cost effective, very simplified. There is no other work. Main advantage is there we developed the system for the existing supplied panel. Even 5 years, 10 years before even supplied, that panel can be connected by a IoT device and it can be connected to the automation. So that the entire substation. So that what happens, that you are connected to the relay, through the relay you can able to see the current and voltage, and as well as when the fault current tripped, what is the time tripped, and whatever that number of time the operated tripping operation, everything recorded by the SD card. Even after 1 month you can download the data, you can have the data analysis so that you can analyze the data. Similarly, trivector meter reading also, energy meter reading also taken continuously monitor. Similarly, the transformer can be monitored, any input, the substation can be monitored. Hence, we could able to provide entire substation automation through IoT device. So of course, IoT device, knowing lot of equipments are available, but only I need the advantages. Real-time visibility is there. Based on the data, you can take preventive maintenance. So it will be resources you can allocate efficiently. It has enhanced safety feature is there. Because of this IoT device, cost-effective solution is there. Of course, you can quick respond the fault, because the fault will be immediately within 10 seconds. Anywhere in the world, you can able to assess that things. Of course, here IoT security, of course, talking, there is there in the both hardware and software we provided. Still, it is a isolated substation, everything, so that IoT security will not be a threat. So that, of course, future, what is the trend is coming, whenever above 5G is coming or 5G is coming, the SCADA also can be operated by cloud basis. AI power analytics is there, IoT integration for all the grid can be possible, and of course leverage augmented virtual reality, improved situational awareness and remote of course now everybody talking about speed operation 61850 protocol. The relay can be connected by 61850 protocol. Transformer and circuit breaker can be easily monitored. Of course, in the circuit breaker, still that humidity control, temperature control, gas pressure, everything little bit costly. But that is also we can able to think about how the cost-effective solution can be provided for this particular segment. So thank you for that. However, of course, our aim is there. Entire rural substation can be made digital substation if the DISCOM giving the opportunity. And of course, initially we have taken our own panel, because our own panel we supplied in lakhs, in a lot of first, of course, initially we are concentrating outdoor circuit breaker only, because outdoor every time operator has to go to the reading for the summer and rain everything. But by providing this all the things, he can operate from the control room. And as well as, of course, executive engineer, superengineer can monitor the substation when the fault is reported, what is the load current is going on, everything. So thank you very much. That due to time limit, I will complete other things. Thank you for the opportunity giving this all the things. Okay. Thank you.
Thank you, Mr. Selvan. And it was especially heartening to see these applications not just geared towards an urban niche, but across all the types of substations in India. So that's very important. I mean, the SEDI-SEFI and a lot of other parameters are so asymmetric across India. We sometimes lose sight of that. So thank you. Now we have any immediate thoughts before we have a last round of... Okay. Just the last few points since... last thought, which is, what should we do next? In the sense that there's a lot of ambition, but really very quick. Like, what do we need? Either what's missing, or what should we be trying? Or is it just that we have to put our foot on the accelerator? Is that the only thing that's required? Or do we need somebody to take more risk? And with all admiration, I think UP has been taking the risks and putting their money where their mouth is, has turned to ground positive for a lot of these efforts. So, I mean, do we need just to find utility partners? Is it a push or a pull that will really drive this? Or do we just need the government of India to say, this is now the new mandate, and then everyone complies? Or is there another way forward? Any thoughts to the way forward, open to everyone before we turn to our chair?
Okay, so like Sujit was talking about the UPI for banking industry where core banking system was ready. So in case of utility also, because of the IPDS, RAPDRP, those core tech stacks are ready. Some at different maturity level. But like I shared the private cloud for which the data is not available. Even for demand flexibility, I want to work with BPCL or IOC or that kind of institutional customers. So that is not possible because that missing piece of between systems data exchange. So that is what is actually hindering us. That we need to do. That's all actually we need. And for that thing, it's not easy because everyone will come up, every Modbus is different. You know that before DLMS, how the metering protocols were there. So that is where the MOP is coming with the IES. I think that will solve this problem, where actually we'll be able to give that. And then the business cases will evolve, like the aggregators. Why a customer will pay for the same fixed cost with a lower reliability and lower quality, power quality compared to other areas. So this missing piece will bring in more service provider and the current problems. That is what is my take.
I can say like small pithy statements. Educate regulators, very important. 2, DISCOMs need to recover fixed costs. Otherwise, all of this will not work. 1. 3, Don't scare aggregators away with complex force measures. I have seen myself, there was this SBD that was put out. I got scared reading. I would never bid. If I put so many legal clauses, no aggregator will work with us. Please don't scare aggregators away. Without aggregators, all this talk we are doing will remain as a talk. Encourage aggregators, be friendly, let's do something wrong. That's only when we can learn. 3 things. Thank you.
Controlled failures. Limited controlled learning failures.
I will. Oh, sorry.
For the technology to work, we need to have the data source fully connected. That means more smart meters are required, otherwise we will not see data, otherwise we will not see anything happening in the network. So more smart meters, that's what we are anticipating.
Okay. So I will more push for the AI because AI is real. If we are not ready for it, I think we should not look for that. And I'm listening from the morning that we should shortlist the use cases, we should do the pilots. By the time we do that, I think the industry in its own digital journey will move much forward. If we do the data training and start working and shortlisting and
sorry, can you bring
forward,
it closer?
we need to move forward. Sorry. Till the time we do that, I think the industry might have moved forward and the use case may not be useful. So we are watching all the global utilities. They are pitching right now with the limited data or whatever set of data they are having currently. So I will also urge you to start working on that. We need to understand AI. We need to learn. We need to also learn from our mistakes. We need to also optimize and we need to accelerate. That is how I see it going forward. Thank you.
Thank you. I think you flagged one last point that I took away. Learn from each other's mistakes. So A, let's get to the point where we do make a mistake, because that means you've pushed yourself. But B, let's learn from those who are ahead of the curve. I mean, UP is a shining light of that. And Tata's and BSES are, of course, urban Delhi discoms for the large part, or Mumbai, and now Odisha. But again, positive outliers are everywhere. Many states, Kerala has done remarkable things in other senses. Rajasthan and Karnataka are very high in renewable energy, for example. So we have pockets of being ahead of the curve. So we need, I think, this conference is one, IDA is another. There need to be more engagements and interactions. So with that note, if I could now request our chair, and if I could also remind you, you were brave enough to say what happens financially to the utility if we have a lot of rooftop solar peer-to-peer hypothetically.
Thank you so much, Rahul, for being a perfect moderator. Thank you to all the panelists for being extremely candid and also taking us through the nuances of digitization. There are 2-3 things which we need to understand. As Mr. Nagarjuna said, DISCOMs have a lot of work to do. Smart meters have added to certain cost. The recovery is yet to come. Urban centers are always pockets of profit, but the rural centers are where the real challenge lies. A different world is where you're talking about rebuilding energy stack. Probably one of the most ambitious things anybody has thought of in the entire universe or world. US doesn't have a national grid, for example. We have a national grid, and we benefit from that immensely. When we talk about P2P, we need to understand that grid stability is a huge challenge. Predictability of where the demand will come from, where it will flow, is a huge challenge, and that has to be handled equally and very robustly. We have had cases happening in the Europe where the grid has failed actually. So we need to be very cautious about just getting into energy or technology because the option is available. From a consumer point of view, what does a consumer think about? That basically comes from the ease of using it and the benefit of using it. Aggregators help in that because they have come with a big number and they can sell it. For an individual person to do P2P is extremely challenging. Till he knows कि हर दिन उसे कहाँ जाना है, yeah, it is like a BNB. I'm going to be out for a month, then I put everything on the market and go back. As we move forward, P2P might have to develop something like an energy escrow. as we move forward, there will be distributed storage. In fact, with time, you will have to come to a point where P2P, distributed storage through solar, and then escrow of the energy at some level is kept together. So all these ideas are extremely brilliant ideas, and they probably will be tested with time. Consumer behavior is not an easy thing to handle, but that's all the DISCOMs know. I'd like to congratulate Mr. Reggie on this entire P2P experiment which we did in UP successfully, and Sujit as well. So the concept is that, first of all, this is a very regulated sector. हम सब जो बातें कर रहे हैं, regulators साहब उसको एक मिनट में उड़ा देते हैं. तो सब खर्चा ultimately कोई तो देगा. Everybody is talking about which everybody said that the fixed cost has to come to the utility. Otherwise, all these are good talks, but ultimately the burden goes to the government. So we need to be very careful about or very clear about what we are talking about. So what happens in P2P in UP, I'll explain in very simple terms. मेरे घर में सोलर लगा हुआ है, मैं बाहर जा रहा हूँ 3 दिन के लिए. आपके घर में भी सोलर लगा हुआ है या आप नहीं भी लगाए आगे फ्यूचर में चल के, मैंने एक पर्टिकुलर ट्रेडिंग प्लेटफॉर्म पे बोला अगले 3 दिन मैं X यूनिट्स आपको देना चाहता हूँ. And it's an open market. Somebody within that particular utility picks up those particular units at a particular cost. Now what happens is the seller gets some money more because it's at a premium. The buyer gets it cheaper because probably the utilities price is probably higher at that point in time. And to do this transaction, utility gets a particular share because the infra is being used, and the platform gets a share because they are being used. Mota mota yahi hai. Now there are a lot of nuances in this. How do we do the billing, energy accounting? Can it be instantaneous? Can it be at a particular regular interval? Can it be prepaid? All those are design choices, as Sujit said. That can be all worked out. DISCOM at some point has to see what is the benefit coming to it from this. And regulator has to see how does it translate itself into a cost reflective tariff. So these are questions which regulators will have to grapple with time. Technology has to evolve more because consumer has to be given these options. Even when we talk about smart meters today and we say consumers will have the ability to control their usage, we are still not reached that point where we can say that, okay, आपके घर में idle power consumption X चल रहा है. So I get a notification in the morning that yesterday that you had 15 units were spent because there were chargers which were plugged in and switch were on, but was not switched off. It's an idle usage or wastage. So that kind of level of analytics is still to be done. So we need to move in a way where use cases become useful to public and to the utility. So now the entire art is not technology. Technology is there. Might be Beckn, might be blockchain, might be simple technology. Right? But we need to find use cases because only they will make us usable by the consumers. And DISCOMs have a pretty much a neutral stance on this because the more we understand the nature of the consumer, the better we can plan our load and the grid. In the long run, grid stability is going to be the biggest challenge, and that is something we should really work on because predictability of solar, renewable is something which you need to be very serious about. Otherwise, DSM is going to be a big hit on all the DISCOMs. With that, I'd like to thank everybody, especially Rahul, for being a perfect moderator, and Reggie Pillai Saab and ISGF for the entire, and IDA, obviously, for being a voice of the DISCOMs. Thank you so much. Thank you.
I would also like to thank all our panelists, but especially the audience. I did not see a single person get restless and try and walk away. So hats off to the entire audience for joining us for this important discussion.
Thank you so much to the eminent panel here today, and I'm sure our audience finds all the discussions very insightful, and that's the reason we still have them sitting here listening to us till 8 o'clock in the evening. I don't think any session would have run till 8, and we still have so many people in the room with us. So thank you, and a big round of applause for our session eminent speakers, chair and moderator. And a bigger round of applause for our audience members who have been with us through the day. And I really hope that you found the sessions very informative, insightful, and we will be able to see the transformation we are looking for with this kind of platform, networking, and collaboration. So since my MC is out for some time, so I'm going to take the opportunity to thank and felicitate our panelists. I would like to invite our Honorable Chair, Mr. Pankaj Kumar, MD, UPPCL, to kindly felicitate our session speakers. Yeah, would like to start with our moderator, Mr. Dr. Rahul Tongia, Founding Advisor, ISGF, and Senior Fellow, C7. I would like to next felicitate our speaker, panelist, Mr. Samantha Satyaduti, Chief Digital Transformation and IT, Tata Power Company. Please give a big round of applause. Next, we have our panelist, Mr. Adarsh Nagarajan, Consultant, BRPL. Thank you, Samantha ji, for joining us. Next, Adarsh Nagarajan ji, Consultant, BRPL. Kindly come forward for the felicitation. Next, we request Mr. Manoj Muthiala, Senior Director, Sales, Impresa.ai, to please come forward for receiving your thank you token. And please put your hands together for Mr. Manoj. I would like to now request for felicitation of Mr. R.S. Selvam, VP R&D, Stelmac. Mr. Selvan, please give a big round of applause and a wonderful presentation. Next, we have Mr. Ravi Jagannathan, MD of GRIDS. Mr. Ravi Jagannathan, please give a big round of applause for Mr. Jagannathan. Thank you. And I think Mohit ji has gone because of his flight. So I would also like to, and Sujit, I think we'll have to felicitate later. Now I request Ms. Vishakha Chavan, Associate Product Manager, Impresa.ai, to please come on the dais. Wonderful presentation, Vishakha. May I request our President, India Smart Grid Forum, Reggie Kumar ji, to please come on the dais to felicitate our Honorable Chair, Pankaj Kumar ji. Thank you so much, sir, for being with us for this program, as well as for your patience, even though we were running very, very late for today's session. May I request all the speakers to please join for a group picture. Come forward, please. Pankaj ji, please stay for a group picture.